Welcome back to episode 38 of our programming series. Today we're going to introduce the topic of pointers. Before we can talk about what a pointer is, we need to understand one specific operator. This operator is called the address operator or the address of operator. And simply it's the symbol of the ampersand. So if you put this symbol in front of any variable, let's say we have a variable x, it's going to print out the memory address of your variable. Let's go ahead and see an example here. So in our main function, we initialize a variable of type int equal to the value 3. So as we talked about in the last video, 32 bits are going to be allocated statically to this variable on the stack. So now x is in the stack, set to 3, and it takes up 4 bytes because it's of type int, so it goes to 46. So now, what's going to happen when we call the address of operator on x, it's going to print out our 46 here. So now let's talk about what a pointer is. A pointer is simply a variable that holds the address of another variable. So let's go ahead and see an example. So in this program, you can see we're doing the same thing. We're initializing a variable x of type int to the value 3. So the same thing is going to happen on the stack. We're going to statically allocate 4 bytes of memory and set the value to 3. So now this starts at address 46 and goes to 50. Now you can see we're declaring something known as a pointer. Now to do this in C++, you say the type of the pointer, the asterisk symbol, and then the name of the pointer. So what is this doing? Well, all of our pointers are going to be statically allocated in the stack as well, just like our variables, but we'll see the difference in a second. So now we have this p in the actual stack, but what is it set to? Well, we didn't initialize it to anything, so this is going to be set to null. And null, as I think I previously mentioned in a previous video, just means nothing. So p is set to nothing. And remember, pointers store addresses. So p, this really means p has no address to point to. Now, where does p start to? Because it has its own address. It is stored in memory right now. It has its own address. Well, this depends on your specific computer. Every computer is different in terms of how much memory it has and what kind of CPU it has. So let's just take a hypothetical example and say that your computer has 1,000 memory addresses in it that you can use. So in binary, you can see here that the decimal value 1,000 is 10 bits long in binary. So we're going to need 10 bits to store this pointer. So 10 bits is over 8 bits, which is the amount of bits for each memory address. So we're going to need at least 2 bits. So this is going to go from address 44 to address 46. Now in the program, you can see that we're setting the pointer p equal to the address of x. So what is this doing? Well, this is taking the value of p and setting it equal to the address of our x variable, which is a starting value of 46. So this is going to store the address 46. Now what we can do is use what's called the dereference operator. So the dereference operator is the same symbol, it's the asterisk symbol. And what this does is it basically takes the address in a pointer, goes to that address, and pulls out the value. So you can view this pointer as like having an arrow pointing to the x variable, wherever its memory address is, and then it reads the value from that variable. So we can see here that our pointer points to the address 46, but how does our pointer know how many bits to read from that address 46? Well, this is where the type of the pointer comes in. Our pointer is an integer pointer, therefore we will read 32 bits. So it points to 46 and then reads 32 bits and gets that value. So now what we can do is we can print the dereference operator and p, and this will print out whatever p is pointing to. So you can see p is pointing to the value of 3, so that will print out 3. Now we can use our address of operator to print out the address of x, and that will be 46. And if we print out the value of p, so if we just say cout p, that will also be 46 because it stores that address in it. One last thing we could do here is print out the address of the actual p pointer. So if we say cout, then the ampersand, the address of operator, and then p, that'll print out address 44. So that is going to be a really good lead-in into our next video, which is going to talk about dynamic memory allocation.
perfect.